technique of differentiation. For the question 1, what the meaning of differentiation and what are the technique of differentiation? Differentiation is the process of determining the derivative of a function, which quantifies the instantaneous rate at which a dependent variable changes with respect to an independent variable. Geometrically, this derivative corresponds to the slope of the tangent line to the curve at a given point. There are 8 of technique of differentiation, and this is the formula and the example. First, power rule, constant rule, chain rule, product rule, sum and difference rule, constant multiple rule, quotient rule, differentiation of exponential, logarithmic, trigonometric function. Find dy dx for the following function. First, we apply the product rule. Dy dx equal to uv prime plus vu prime. Second, differentiate u and v. Let u equal to e to the power of minus 2x and v 3x plus 1. And find their derivative. U prime equal to minus 2e to the power of minus 2x and v prime equal to 3. Third, substitute the derivative back into the product rule formula. Dy dx equal to e to the power of minus 2x multiplied with 3 plus 3x plus 1 minus 2e to the power of minus 2x. And lastly, simplify the expression and combine. Dy dx equal to e to the power of minus 2x minus 6x e to the power of minus 2x. And you also can factorize it. Dy dx equal to e to the power of minus 2x 1 minus 6xe to the power of minus 2x.
Question number 2b. The function is y equal to zx plus sin 3x. So the first step is we look to the zx. Instead of using zx, we can rewrite it as x power of 1 over 2. And then I differentiate x power of 1 over 2 using the power rule method, which is multiply by the power and subtract 1 from the power. And then I change 1 over 2x power of 1 negative 1 over 2 into a simple form and get like 1 over 2 third x. So the derivative of third x is 1 over 2 third x. The derivative for sin is cos, and because inside is 3x, I multiply by 3 and get 3 cos 3s. So derivative for sin 3s is 3 cos 3x. So after that I combine these two derivatives and get the final answer. Y equal to 1 over 2 third x plus 3 cos 3x.
Question number 3. So, given e power of 2y plus 2x equals to y cubed plus cos 4x, find dy over dx using implicit differentiation. So, for implicit differentiation, we need to use explicit function and implicit function. First thing first, we need to write down the equation and multiply the equation on the both sides by d over dx. After that, we need to expand the equation by multiply d over dx on the both sides into the bracket. After that, this is the equation after we expand the dy over dx. So by using that equation, we need to differentiate the equation, and this is the equation after we differentiate it. So after that, we need to make sure the left side only contains the dy over dx and the right side only contains the others number. So to do that, we need to bring 3y power of 2 dy over dx to the left side and it will be negative, and bring number 2 to the right side and it will be negative also. Next, this is the equation after we make sure the left side only contains dy over dx and the right side only contains the others number. After that, we need to simplify the left side by taking out dy over dx and put the others number into the bracket. So this is the equation after we simplify the left side dy over dx. So the answer will be dy over dx equals to negative 4 sine 4x minus 2 over 2e power of 2y negative 3y power of 2.
Moving on to question number 4, it asks us to solve this problem using linear approximation method. So the formula of linear approximation is given by the sum of fx naught and f delta x equals to the sum of fx naught and f prime of x naught multiplied by delta x. So the formula of delta x is also equal to x minus x naught, and x here in this case is the given value, which is 124.99, and x naught is the closest value to x and is also an integer. So we'll choose the value of 125. Then plug in these two values into the formula of delta x and we'll get negative 0.01. So then we're going to find the function of x. And to do that, we have to change the value of 124.99 of this whole equation into the variable of x. So we'll get 1 per cube root of x plus cube root of x with the power of 2. And to simplify it, 1 per cube root of x is also equal to x with the power of negative 1 per 3. And cube root of x is equal to x with the power of 1 per 3. And then power of 1 per 3 will have to multiply with the power of 2, which will make it x with the power of 2 per 3. So this is the complete equation for function of x. Then we have to find the prime f of x, and to find it, we have to differentiate the whole equation of function of x. To differentiate it, we have to take the power of x here, which is negative 1 per 3, moves it in front of x and minus 1. So we'll get negative 1 per 3x with the power of negative 4 per 3. And this one goes the same. 2 per 3 goes in front of x and minus 1. And we'll get 2 per 3x with the power of negative 1 per 3. So this here also is the complete equation for prime f of x. And the last step is we have to take both of these equations, which is the equation of function of x and equation of f prime of x, and write them back following the formula of linear approximation. So here is the equation for function of x, and in this bracket here is the equation for f prime of x, and this is delta x according to the formula of linear approximation. So next we want to substitute the values of x naught and delta x. So value of x naught is 125, so just substitute 125 into x. So 125 here goes into x, this one here goes the same, 125 goes into x. Then substitute the value of delta x, which is negative 0.01. Then calculate this whole equation and we'll get 25.198672. And since the question wants us to write the final answer into 3 decimal places, so the final answer will be 25.199.
In conclusion, the technique of differentiation is important because it helps us to find how fast each function is changing. By using different rules such as chain rule, power rule, product rule, and quantity rule, we can handle different types of expression in science, engineering, or business, where we want to know how fast something is moving or changing. Overall, this technique makes difficult expression easier to handle and help us to solve real mathematical more effectively.